the ability for us to understand the semantics of the scene. So in this case, things like this is a ceiling, this is a wall, this is a floor, things which are pretty evident to humans, but are not so evident to computers because they're just pixels. So you can easily detect what's a line and an edge, or you can detect a corner, but detecting more semantically meaningful things like walls, planes, or even things like people is a harder problem. So that's what currently I work on the scene understanding side. And object recognition.
Well, actually, let me back up a little bit. I guess why is it important to be able to detect those walls?
Yeah. So things like semantics really help you in like for I can give an example. It's very useful for something like an AR experience like Dr. G, which is like the game which you guys will try. You could build these semantics into your gameplay. So imagine I know that this is a chair, so then the virtual agent would sit on the chair and actually behave like it knows where you are. If it knows that there's a floor, it will treat it differently from a ceiling, and if it knows it's a door, it will come through the door instead of any wall. So it's all about making it more realistic as we get into more into the magic words, as what you would like to call it. So we would like to make it more realistic and add more semantic capabilities to our platform.
So I guess in this sense, you're basically teaching the machine how to understand the environment, not just from a spatial perspective, but actually from a semantic perspective, which is the actual qualities of the elements of this particular object. I see. Okay, and sorry, I interrupted you while you were going into object recognition.
So object recognition, as it says, is more about how to detect objects in the scene. In the 2D space, it's a lot has been solved in the academia. But we are dealing primarily with 3D, as you said, it's spatial, so we want to detect objects in the scene and the 3D extent, and then utilize them for similar things like can we use this in a game, or can we use this in a virtual agent for AI, stuff like that. So.
Right. So I guess I don't want to spoil too much about the demo, but I guess like how is what you're working on? I guess like on the object recognition part, is that part of the demo as well?
Not this one, but that's one of the things which we'll be rolling on.
Got it, I see. And so moving a little bit more away from the computer vision side, what do you like to do when you're not essentially working on computer vision?
So I do like to travel a lot. So I try, and as Ali was mentioning, we have pretty nice offices across the country. So I try to travel. We have offices in Boulder, we have offices in Dallas, Austin, and Florida, and so generally, Miami is a pretty nice place if you want to party.
Okay.
So,
right, really close to Plantation.
Yes.
Well, how long is that drive between Plantation and Miami?
It's just an hour.
Just an hour? Okay, I see.
So, I mean, I like to travel almost, especially in national parks, so I try to go to a lot of, like, went to Grand Canyon last year, so it was pretty fun, so I like to travel and hike a lot outside work.
Got it, which I guess NorCal is fantastic for, right? And how long have you been in Silicon Valley for?
Almost 4 years now.
Almost 4 years now, huh? Okay, I see. Okay, great. I think I'm ready to bring everybody back up actually for the A team. Yeah. All right.
Just go ahead and handle the mic any way you want.
Sure.
Make sure it's fired up. And then we're set. And is this high enough for you guys?
All right. All right. All right, there we go. So now that we've heard from each of our speakers one-on-one, I want to bring all of them back up to more address the more overall arching computer vision as well as augmented reality type of issues. So while we're going through these questions, definitely brainstorm some of your own to ask speakers during the Q&A session as well. So my first one, we're going to dive right in, which is, AR has been touted as like the next computing platform, right, after mobile, with a lot of, pretty big promises as well. So, in terms of actually reaching some of those promises, do you think, what are some of the biggest technological hurdles that we still have to cross over? Another way to look at it is AR already a, anytime, anywhere used for any kind of scenario type of technology yet? If not, what are some of the things that really still needs to be improved by leaps and bounds in order for us to get there?
I can start then. So yeah, I think in my view, so like if you think of these glasses, this is the only thing it helps you do is to just see, and it makes you improve your vision. But what if every person who's wearing glasses is also wearing an augmented reality device? So then it would make it much more comfortable. And so to get there, what it means is I need to be able to build my AR device in that form factor. So that includes all the optics, it includes all the compute, the battery, and all the sensors that go with it, and also last an entire day.
Right.
So then you wouldn't mind charging your specs once a day if it's helping you do everything that it's doing right now to help you see better. And in addition to helping you see better, it also augments the world with whatever content that you want it to be used for. So to get there is the leap that we eventually want to get there from an AR community perspective. And how to get there is in terms of steps, and that's what every company in the AR space is working on, in different kinds of steps. And in Magic Leap, we started out working with the kind of device that we have, and the goal is to eventually get to that form factor, to a point where each person in the world is able to wear a specs and it augments information on them.
I see.
Yeah, I would add that it's actually a much wider problem of adoption as well, and so by the community and also the scientific progress that in many fields, for example, optics, display, battery especially, that can actually make this a ubiquitous device. If you think about it, holding phones and staring at them while you're walking on the street is not a very natural, safe thing to do, but everybody seems to be doing it, especially here in the city. But if we could actually use our glasses to reach that information, or use our voice, for example, to communicate the emails that we're composing, etc. And if we have useful apps that are developed by the community, I think that would start a kind of a trend that would help both the technology and the industry to catch and produce something that would be much more widely used.
I definitely would agree, and I think primarily, at least from the vision or the technology point of view, compute is one of the biggest things we look forward to, which I think will really improve going towards all-time AR, like on the all-the-time AR. It's getting better, but that's definitely something. As it gets more powerful and stronger, combined with battery technology, will help on the CV side for sure. Like a lot of the algorithms, the research currently uses very beefy GPUs, which is almost impossible to put up on a person's head. So as these models get into production, they require to be much cleaner and need to run on these very compact, powerful chipsets, and which are not yet there, but I hope in the next few years they will be there, and that will really spur a lot of this work towards all the time.
Yeah, but I think it's the device perspective, like eventually we get there. The way I see those is like layers of infrastructure, right? Just like you may have internet working in year 2000 or something, but you only really actually use internet banking once you have enough of a traction, the security infrastructure and so far. For this kind of medium, like the use cases, like people can theorize what the use case would be, right? But no one truly know how it's going to look like 10 years from now. And then people who are starting to develop today, they're kind of the first pioneers of the internet, right?
Yeah.
Maybe someone created Amazon or something like that, right? It looks like doesn't look like ideal, but those are the seeds that would grow. I think the overall ecosystem has to grow with all the AR companies device.
That's actually really interesting because it sounds like the form factor definitely needs to go down, but in addition, all the technology and all the chipsets, the hardware innovations that needs to go in there, but also the ecosystem as well.
Yeah.
It's almost kind of like it's almost a chicken or an egg type of thing, right? Because if the device is not quite there yet, and application developers might not feel like it's worth their while from a distribution standpoint to actually create the applications. So I guess at Magic Leap, how do you intend to address that chicken or egg issue?
Well, if you look out there, there's actually a lot of traction. I mean, you can follow mobile as an example. Mobile was like, oh, it was a niche market for enterprise, right? And then it eventually crossed the threshold. It was okay, that's good enough, just good enough for consumer. At the same time, all the like 3G or not even 3G data infrastructure for mobile, you could do just enough to do emails and stuff like that. And then that kind of picked up, right? And by the time it picked up, if you're not already there, you missed the wave, right? At least the way I see it for our market would be the same, right? It's like not ready yet, not ready yet. The moment it's ready, it's already too late to get it. That's how I see it.
I see. So the early movers advantage for the applications.
Yeah.
I see. Okay.
Yeah, I was just going to add that I think mobile phones is a very good analogy for this. And so at Magic Leap, we're mostly focused on building the platform. So it's more like the underlying framework that lets developers and end users build applications on top of it. So all the work that we're doing is to build a core so that people can start thinking of creative ways to use the device in a way that they can create more applications. Like it's the early days of like iOS or Android kind of cases where you have the core platform, like the mobile ecosystem, but then you need all the applications to come in to enable this ecosystem to make it big as we are using it right now.
Makes a lot of sense. And I guess while we're in the OEM or the hardware parts, there's been an increasing trend amongst the handset manufacturers to put more like cameras on devices. Do you think that would reduce the motion requirement for SLAM for AR, basically for these devices? So actually, a quick background actually. In terms of SLAM, I mean, the way that if anybody has used the AirCore AirKit, it requires you to put the phone camera like this and then start moving around for it to nap. This is essentially SLAM at work. But this basically puts a UX tax effectively on the user because even for your experience for launch, you actually have to move around. And if you're in public, that might look a little bit weird, essentially. But anyways, to experts.
Yeah, I mean, the more information you have, of course, you can make a better job of estimating the exact position of the device in real time. But I would also say that it's also a question of software, and the more intelligent the software and the AI technology that we can add on top of that, we can get more out of or fewer sensors at the same time. And so there is a balance between adding more and more sensors, which has its own footprint and impact and weight and power and everything and cost, as opposed to using smart algorithms to extract the right information to help you make the right estimation.
So I'd like to add, like, especially in cases, as you said, you're right, the motion is required, especially for SLAM, because it needs to initialize. But even now, if you have a depth sensor and IMU integrated, you can easily get it away without that. But it's always the cost of power and compute, right? So you add a more sensor, you have more. Now you're going to consume more power, so you have better battery, and you require more compute to process it. So it's not always like a linear. I think that if you add a camera, and it's going to definitely help you. So you definitely can do some smart, intelligent algorithms to there's a minimal number of cameras, and but still get to most out of it.
Right. So it's not just about the number of cameras; it's actually the optimization, actually taking in the right data for that makes sense. Okay. And I mean, we've earlier we talked about the form factor, and that keeps on coming up as well. What are some of the advances that's happening either on the hardware or software side that will help essentially reduce the form factors while still producing the good results for AR? Any specifics, I guess, like innovations or you guys are excited about?
I would say there are a lot of exciting stuff, and I'll be kind of abstract here, but
Sure. Without giving too much away. Okay.
But I'll say the biggest jumps happens when people go back to the basics, right? They start looking at stuff like on a physical level, like is this needed, is it not needed, what exactly needs to go in or not, and that's actually what can drive reduction in terms of weight and volume and so forth.
Okay, so keep on cutting it down, right? Okay. Okay. Well,
I can probably add
Sure.
that. I mean, with the advent of 5G internet, for example, we might be able to do a lot of heavy load compute on the cloud actually in real time, and that would definitely help with just boosting the performance on the device and actually reducing its hardware at the same time.
Right. Can you elaborate on the 5G part? Primarily because, at least in the U.S., the telcos are playing a lot of marketing games around 5G. But can you elaborate a little bit more about 5G and mobile edge computing that could help essentially with AR?
Just generally speaking, I think it has like broader bandwidth and speed support, and it's specifically tailored for, as you mentioned, edge computing and, for example, autonomous navigation.
Sure.
That might require a lot of connectivity, very reliable connectivity, and actually mixed reality can definitely benefit from that. And it's in many ways it's a better platform to integrate into 5G because autonomous navigation is still in its infancy. And it needs a lot of regulations, regulatory alignments, and adjustments. So I think this is definitely an area where IoT and mixed reality can impact the 5G integration.
And what is? Do you want to add anything?
So yeah, I was going to say that. So using cloud is one of the cloud gives you the capability to run sophisticated algorithms to take that huge leap for it kind of offsets all the compute restrictions that you have on device and moves it elsewhere.
Right.
But at the same time, it also comes with the other part of it. Like you don't want all the data that you have to be sent to the cloud, and at Magic Leap we are very careful about that. We respect users' privacy a lot. So we want to really care about what data is being sent to the cloud and when, and make sure that end user who's using the device is fully aware of what is being sent and when it's being sent and what is being used and what's processed in the cloud and what's processed on the device. So I think that's something that's very critical for most augmented reality companies as well.
Sure.
So that's why it needs to kind of work both ways, where the compute on device also needs to it needs to improve, get better, and at the same time use the cloud for things that make sense, like for things where you're sharing content or things like that, which enables different kinds of use cases.
Got it. Actually, that sounds like it might be related to your 2016 paper on cloud-assisted AR platforms.
So yeah, so that was before my Magic Leap days, but I was looking at that point that so there are things that the devices are very good at, like the computer device can actually do well.
Right.
But the moment you start looking into very large scale scenarios, like I want to detect every single object in my room. If I want to go to a city scale kind of infrastructure, or so back in those days I was in Qualcomm, I was looking at can I recognize every single DVD that's being produced in the world.
That's right, yeah.
So even looking at, so that was the context for the cloud assisted project that I was working on, and when you look at those kind of scales, you don't have data for every single DVD on your mobile phone. You don't have it in your compute constrained platform. So then you are relying on your the cloud to help you do the compute. So it goes back to what Helder was talking about, right? Infrastructure and Google search engine kind of thing. So then you use that backend infrastructure, which is being built by other companies, to be able to create that, to bridge that gap.
Got it.
So that was what I was working on in Qualcomm. So the idea there was I should be able to look at a DVD and I can play the movie preview on my DVD.
Got it. Right.
Right. So it's a cool use case. Think of you going to a store and you can you use your phone or a magic device or any augmented reality device and look at a DVD and it automatically recognizes the DVD, plays a YouTube video of the preview of the movie.
Got it. Right.
So it helps you choose what movie you want to watch and make it a good realistic experience.
I see. Got it. And actually, I mean, regarding what you said about the cloud part, it's actually very fascinating because this is exactly what Sturfy, basically my company, works on, which is a city scale type of AR, which is really on the premise that the cameras today is, you're able to detect essentially room scale type of objects. However, at the city scale, a lot of the depth sensing kind of fails. So, and also it takes a lot of processing power to actually, the further the objects are in order to actually process it and render it. So the hypothesis is, what if we can render all of this already in the cloud, essentially beforehand, build all the 3D, assets essentially of the buildings, and now we only have to figure out exactly where you are. If we can figure out, localize you effectively in the world, your orientation as well as where you are, then we can actually load the 3D models to the device. Therefore, 75% of the scene has already been solved. So I'm really glad you actually brought up the cloud part because that's what I think about day in and day out. And actually, speaking of Sturfy, one of my colleagues actually really wanted to ask you guys this, which was, what is the next big thing in computer vision after deep learning? He's a PhD in computer vision himself, so I was kind of curious about what you guys thought about that.
So I'm currently I think definitely with the deep learning, it's primarily focused on supervised learning, where you're providing labels, so you tell the exact thing, what this is a chair, this is a couch. I think we feel that at least I feel that the academy is primarily moving towards unsupervised or semi-supervised, where basically things like semi-supervision in this case would mean like a pose, like given that you have a video, so you just label the first frame and all the frames in the next are basically propagated from the first frame. Or unsupervised means things which are could be very close to each other. Could also allow you to learn things which are unlabelable, because there are millions of videos out there, but it's almost impossible to label all those videos each frame. So if there's a way to learn from these videos, that will provide a huge amount of learning just towards what most humans can do through contextual learning. And I think this will finally move towards active learning, which is what we are definitely missing, where people just know a fixed set of categories or classes of what people can, what you can recognize, but it's very hard to add new categories. So, and that's something which I think most of us have, to learn new things on the fly, and that's definitely something which machines would require if you want to generalize to things in the world. So.
Yeah, I'd probably add, for example, right now we need to define the network architecture for deep learning and then have an enormous amount of training data to train those networks. So I think maybe one day the networks can architect themselves and also work out data or hallucinate data, and also, I mean, right now the deep learning work is not still mature in areas, for example, in 3D geometry, scene understanding, whatever involves kind of spatial computing that we might need for kind of situational awareness. I mean, that's still lacking in my opinion.
Yeah, I would say that, machine learning is bounded by compute, but also bounded by data, right? So if you think of the big data sets that came labeled, that kind of with the compute enable the big advances with deep learning. The next frontier, in my opinion, would be contextual data, right?
Mm-hmm.
And that you can only have if you have a device that is aware of the context, so you can actually capture the data at a large scale, right? So
Yeah.
taking all the cues from the environment, the cues from the user,
Mm-hmm.
getting the data in the right context, like certain factory operations or something like that,
Mhm.
and not just a still photo of, I don't know, animals or something like that.
Right.
And then at the same time, the actual compute should do something with the data.
Mm-hmm.
That it's there in the cloud if you want to train models, but if you actually want to deploy that on device, that's
Yeah.
pretty limited.
That's actually a really good point, Holder, and that kind of brings to the point where, you know, in the mobile and desktop world, everything is 2D, right? And all the data sets, a lot of the data sets that have been collected is also based on 2D world. If you look at Google Maps, I mean, Google Maps is a little bit different because Google actually, you know, work with malls and, you know, stuff like that to figure out the levels and stuff. But for the most part, let's say you have like a map full of point of interest data. All of this is actually based on lat long. There's no altitude. All of this data is collected and categorized and served to users in a 2D world. So let's say, you know, Magic Leap is in this small form factor tomorrow, and we want to create like the Yelp for tomorrow. Unfortunately, Yelp would not be able to tell the first floor from the second floor from the fifth floor, and show you the POI is probably in the right place. That kind of requires some company, essentially, to, you know, generate that feedback loop for people to perhaps tag it, right? To even start creating a 3D database of the POIs. And that's just one example, basically. So perhaps it's not even the hardware or the algorithms that could be the bottleneck. Perhaps it is actually the underlying data that feeds into it and displays the user. Anyways, yeah. Don't want to monopolize the panel, but any questions, actually? Yeah, over there.
I have a computer vision question. So right now, for example, Lens can detect an object, like let's say a box of cereal in like a second or two. How long do you think it will take until we can detect like an entire shelf and surmise things about those products?
I'll try to take this one close to what I do. I think it's primarily depending on the compute. So even now, it's possible, if it's on the device, then definitely it's harder because you probably want to go through the entire image and detect each object. So even now, most of the computer vision algorithms run on the entire image, and then it generates object proposals for each object in the field, and then classifies each object proposal depending on what object it is. So if given the compute, yes, you can run most of these vision algorithms on the mobile platform, and then hopefully it should be within a second you should get it. But if it on the cloud, it should be possible even now. It's primarily a problem of compute. From the vision perspective, it's still able to get most of the objects in the scene or in the shelf. About the context, it's still a pretty hard problem, defining that if it's a bookshelf versus it's a shelf in the living room. That's definitely a much harder problem and will require a larger amount of study in the scene field, or even require input, because a lot of these contextual questions are which even humans don't do well at. Like, am I seeing the object in the mirror or is it in the person's hand? So those are trickier questions as we move towards understanding the contextualness in the scene.
Over there.
Oh, thank you. Okay, so we do very large presentations with your devices, of course. And we have a big one coming up with the city of San Francisco. We started doing their navigation centers. And, okay, when are you guys going to get live streaming solid? Because right now, if we only have 2, 3, 4 people in the headsets, the public can't engage. People are just going to stand there and they're like, oh, what are they seeing? When are you going to get live streaming solidly down so we can get a whole public to tune in with their phones and really start to see what Magic Leap can do?
So actually, I think the 95 release, right? Stream Friday.
But that's limited to people.
Oh yeah. Yeah, there is a first-person streaming functionality. I think it is beta.
The latest OTA.
Yeah, the latest software release, I think just from last Friday.
Right, it's not working.
Okay. Yeah.
You don't have to run forums anymore. We got this data.
No, it's a good thing to raise it up and say, hey,
Yeah.
guys.
Yeah.
Cool. Nice.
You know Magic Leap has the power pack and the heat pack, right? Aren't you using the phone to do that instead? Aren't you connecting the thing to the phone, which everyone has? You don't have to carry an extra device. already has a battery. Once you're doing that, and
It's got a Snapdragon 845 chip in there.
The phones, I don't think any phone has any, like, I mean, as much compute as the power pack in terms of battery and power, but also in terms of latency, like you need to drive graphics, so there's a custom-made cable and all sorts of.
The power pack has an NVIDIA X processor, which is primarily used for games. Like you'll see, you can actually run high-end games, which you'll see on PCs, on the build pack or the power pack. It's not possible to run such high-end performance games on mobile phones. Like it has a very dedicated GPU, especially for applications which require gaming and immersive experiences.
so for Apple has ARKit, right? So you're saying the peak power that's required for running ARKit is much less than what Magic Leap needs.
It's more of the power of the application itself, right? So I guess it depends on how much the application is going to demand.
What if you were to do it? Let's say a Magic Leap down edition comes out where there's no power pack, right? I don't want to carry an extra power pack around. Is that possible?
I guess technically,
Should be, right?
yeah.
I mean, like, sorry, to go on that, but is there like a bit rate, like cut off between the power pack and the losses? You know, does it need to have like a, I don't know, 500 megabytes per second speed between the two, or you guys?
This might be a good question for offline as well.
Okay.
Yeah, cool. Okay.
So in terms of any future of SLAM or any of its variants, is there going to be a change towards semantic tracking versus, say, plane finding? For example, if I were to take my living room and cover it with the ping pong balls and have very dim lighting at the same time, would it, probably maybe at this point, it would provide better tracking, but is there a trend towards just like it tracking sofas and tables, specifically as sofas and tables versus just edges of planes, or would that provide good tracking if that were the case, like randomly arranged ping pong balls?
So I think it's an active area of research. So we are, I think even the academy sort of divided on it, that you can, I mean, we obviously want to understand the world more semantically meaningful, but if you can use it for tracking as well as points and edges is a question. We think we can, but the problem generally with sofas and chairs, as I said, is like there are only X number of objects in the scene, while generally corners and edges are pretty easily found in the scenario and easily localizable as well. So chairs and we want to move to just purely semantically meaningful maps where you just want to store data which means this is a chair, this is a couch, and just track it. But it definitely becomes harder in the context of them being so few in the world. Like your home might have one chair, one sofa, and maybe a TV. And if those are the only objects they're tracking, the chances of it failing are much higher than if it's tracking probably